not an example in terms of these calculations, just an example in terms of the structure that you see in TS diagram. Again, we go straight to the Eurafrican Mediterranean Sea and we look at the outflow from the sea into the ambient North Atlantic. Okay, we're focusing on the outflow through the Strait of Gibraltar, this area here. And this is the Eurafrican Mediterranean Sea, and it creates a specific characteristic of the deeper water masses because of essentially convection, which creates hypersaline deeper waters in this area. Yep. Not okay, I just show you some examples. So this is what we call a concentration basin of a Mediterranean Sea, where you have an outflow of denser water across a sill, shallower. This is a constraint. You have shallower water depth in a certain region. This is the Strait of Gibraltar. What creates this outflow is a density difference. Heavier water on one side compared to lighter water, and creates an overflow. Okay? The water is denser than the water at the sill depth, so it continues to sink deeper until it finds a density horizon where you have lighter water above and heavier water underneath. And this is at about 1,000 meters. So it shows you here on the bottom panel. Again, it's a vertical transect. You look from the side. The Mediterranean Sea is on the right-hand side, and the ambient Atlantic Ocean is on the left-hand side. And you can see this overflow of water, and it leads to a layering at a depth of 1,000 meters and a spreading, horizontal spreading at that. Okay, and you can identify at that depth a layer which is more saline than the layer above and more saline than the water underneath. And what keeps this layer there is the balance that comes from the temperature. Yeah. Let's have a look at the salinity. Let's have a look at the TS. Yes, I've shown this before. You might be surprised. You see the same stuff over and over again. This was already discussed, but this is actually an example of measuring, observing the outflow from the Eurafrican Mediterranean Sea and the ambient Atlantic Ocean. Okay, and in observations which show the outflow, which contain the outflow, and in observations which do not contain the outflow. Okay, you can see this structure of the outflow. And let's go straight, without wasting too much time, into the TS diagram. You essentially have water above and water underneath, which can be characterized by a water type. And you have the Mediterranean outflow water, which gives you this red dot, gives you the water type, and you get mixing between both. There are two mixing lines, and you can see it in your observation. Here you get a no structure. Okay. So this is clearly the signature of the Mediterranean Sea, of the outflow. So why do you get it? You measure something like 50 kilometers away, and you all of a sudden you don't get that signature anymore. And what scientists have discovered is that the outflow is actually not everywhere. It's actually also creates something which we call eddies, okay, that exist at a depth of 1,000 meters. So there are mesoscale structures that scientists have called MEDIs, Mediterranean Sea eddies. Okay, rotating lands, Mediterranean water. So in some observations, you see the Mediterranean water So if you now want to know how does the Mediterranean water on larger scales spread, you can indeed go back to one figure that I already presented to you in a lecture. And this is shown here again, horizontal distributions of salinity and temperature at 1,000 meters. Okay, this is not the surface, this is at 1,000 meters. And here you can spot the outflow of the Mediterranean Sea in terms of a tongue of salinity, high salinity at that depth, spreading over to the other side, zonally, over long distance, horizontally. And what maintains that level, that salinity, this hypersaline layer of salinity at that depth, is actually a relatively warm temperature effect. You can see the temperature here in this observation. Okay, although there are MEDIs on smaller scales, on larger scales the MEDIs create a mixing, and you can identify again the overall larger scale effect from these distributions. Okay, so locally, and you do one measurement, you might be on the wrong spot. Okay? So this is the storyline.